Okay, welcome back, Science 10s, to our next lesson in Chapter 6. This is 6.3, and today we're going to be looking at graphing work. Now, we've seen two equations for work, and the first one was work is equal to a change in energy, and the second one was work is equal to force times distance. These are both useful formulas, as we've seen in the last lesson for calculations, but today we're going to be focusing on how to graph this equation, the force times distance equation. So let's first just set up a graph with our y and our x-axes, and we're going to be putting force on the y-axis, and that's going to be commonly measured in newtons, and then we're going to be putting distance on the x-axis, and that's commonly measured in meters. So let's consider a situation where some work is being done. Let's say someone is pushing on this box, and they begin pushing with 80 newtons, and they push with a continuous 80 newtons for 5 meters. How we would put that on the graph is I would start with 80 newtons on my y-axis, and that's where we're going to begin. And then for an entire distance of 5 meters, that's how long we're going to be pushing at 80 newtons. So we get a straight line moving across for a y value of 80 newtons, and it goes for a distance of 5 meters. Now, how we're going to get work from this is we're going to consider area under the curve. So I'm going to take my white line here and just draw some dotted lines down to the x-axis. What this is given now is it's given me a visual of the area underneath of this line. I know it's not a curve, but area underneath the line sometimes is curved, and so this is called area under the curve. Now, how I'm going to calculate that area, this is a pretty easy shape. It's just a rectangle. So I would just calculate base times height. Okay, my base would be 5 meters times by my height of 80 newtons. Okay, and that would give me a number of 400. Okay, to consider what this means, let's look at what we did. We took the distance multiplied by the force. This is the same as force times distance from this equation. So then what my area must equal is it must equal the work that was done. So the area under the curve is equal to the work. And that's pretty much the whole concept for this lesson. Find the area under the curve, and that represents work. But let's just do one more example where the graph might look a little bit different. So now let's consider another person pushing on a box, and we'll say that off the start, they are pushing with 0 newtons. They're not pushing yet. And then they're going to increase the amount that they're pushing up to 100 newtons. So start not pushing, but then push it 10 newtons, 20 newtons, 30 newtons, all the way up to 100. And by the time they get up to 100 newtons, they have traveled 5 meters. What would this look like? So let's draw our graph again with our y and our x-axis, the force in newtons going on y, and the distance in meters going on x. Now we're starting with a force of 0. So I need to begin down here. That's my starting position and my starting force. Then after 5 meters, so I'll put 5 here on the x-axis, we can go up to a force of 100 newtons. So I'm going to put 100 on the y. So this is our starting point, and this right here is our ending point. So I'm going to assume that we evenly increase the speed here. So I'm going to draw a straight line that we increased linearly from 0 to 100. To figure out the work done, now I just need to find the area under the curve. So again, I draw my dotted line down and see that this gives me the area of a triangle. Still not too hard to calculate. The area of a triangle is base times height divided by 2. My base is 5, my height is 100, and this is divided by 2. So we get 500 there, divided by 2 gives 250 for our work. So 250 joules of work was done in this scenario. And that's it. That's the whole concept for this lesson. So hopefully that helped you to understand graphing work and area under the curve. Thank you so much for watching, and I will see you in the next video.